Hello, now we are going to solve a numerical problem from the resolution of forces. So here's the problem. Two bars AC and CB are hinged together at C as shown in figure. Find the forces induced in the bar. Assume the weight of bars as negligible. Okay, so there is two bar AC and CB which is hinged at the point C. We need to find out the forces in AC and CB bars. Okay, so the figure is given and all the dimensions are given. So we are going to find out the forces in AC and CB. So first, we are going to assume that this bar AC and CB both are in tension. Alright, so considering that, we are going to draw a free body diagram. Okay, so first I'm going to draw a free body diagram like this. That is, we know this point C, this point is the hinged point, and from there we have bar AC and CB. So this is our bar AC and this is our bar CB. Okay. So I'm considering these two bars in tension. That is, tension means that's why I'm giving this arrow is like this away from the point C. This is the force in bar AC, that is FAC, and this is the bar force in bar CB, that is FBC. Alright. So there is an angle theta 1 and theta 2. We need to find theta 1 and theta 2 first. For that, the dimensions are given. That is, this 0.3 meter and 0.4 meter is given. From with help of that dimension, we can find out the value of theta 1. That is, theta 1, we can take the tan theta 1. Tan theta 1 is equal to, what is tan? It is opposite side by adjacent side. That is 0.3 by 0.4. Okay, from that I will get theta 1 as 36.87 degree. Similarly, I can find out tan theta 2. So tan theta 2 is equal to, opposite side is 0.5, 0.5 by 0.4, which is equal to, from that I will get theta 2 as 51.34 degree. So I got theta 1 and theta 2. We know the angle theta 1 and theta 2. Now the next thing is that I'm considering the equilibrium of force here. Okay, that is, the equilibrium of force is about point C. So we know that if the forces are in equilibrium, then the sum of horizontal components of forces sigma fx should be 0 and sigma Fy should be 0. So I am going to consider these equilibrium equations here. Sigma Fx equal to 0 and sigma Fy equal to 0. That means I am going to resolve the forces first. So there are two forces, FAC and FBC. So we need to resolve these forces along x and y direction. So similar like the previous video, I am going to resolve the force FAC. This is its x direction and this is its y direction. Similarly, FBC, the direction of FBC is like this. So this is my x direction and this is my y direction. Okay, so we know this angle theta 1, that is 36.86. So this theta 1 and this is also theta 1, and that is 36.87. Here, this is theta 2, that is 51.34. So this angle is 51.34. Okay, so I'm resolving the component at near to the angle side is cos component and away from the angle side is sine component. Here also near to the angle is cos component, away from the angle is sine component. Okay, so from this figure, sigma fx, we can write it as sigma fx is equal to, look for FAC, the direction of x component is towards the left direction, that is opposite to the x direction, that is minus F AC cos 36.87 degree. And for FBC also, it is in the left direction, that is away, opposite to the x direction, so that is also negative, minus FBC cos 51.34 degree equal to 0, because we are considering the forces are in equilibrium. Okay, so I can write it as, I am multiplying all the equation with negative sign. So FAC cos 36.87 degree plus FBC cos 51.31 degree is equal to 0. This is my first equation. Okay. Similarly, I am going to consider sigma Fy equal to 0. sigma Fi equal to 0 means sum of vertical components. So here FAC sine 36.87, it is in the upward direction, so positive, and here it is in the downward direction, so minus FBC sine 51.34 degree. Here one force is also acting. Okay, that is 1200 Newton. It is in the downward direction, so minus 1200 equal to 0. Rearranging this equation, I can write it as FAC sine 36.87 degree is equal to 1200 plus FBC sine 51.34. This is my second equation. Okay, so from this two equations, you can either use a calculator and directly input the values. You will get the solution of FAC and FBC. You can directly do that with the scientific calculator, or you can just simply by solving the equation, we can find out the value of FAC and FBC. Okay, so that is how from first equation we know that FAC cos 36.87 degree plus FBC cos 51.34 degree equal to 0. Okay, from this we can find out the value of FAC or FBC, either FAC or FBC. Okay, so I am going to find the value of FBC from this equation. So FBC is equal to minus cos 36.87 degree divided by cos 51.34 degree into FAC. Okay, that's from this I will get the value of FBC as minus 1.29 FAC. Okay, now I am going to substitute this value to the second equation. Okay, so I'm going to substitute this to the second equation. So I will get this as FAC sine 36.87 degree is equal to 1200 plus, from in place of FBC I can substitute minus 1.29 FAC into sine 51.34 degree. Okay, solving this equation, from this equation I will get FAC as 750 Newton. Okay, by substituting here I will get FBC as minus 97.5 Newton. Okay, so this is the final answer. Tension or the forces induced in the bar AC is 750 Newton, in the bar BC is minus 967.5 Newton. And this negative sign implies that the member BC is in compression. We assume that both the bars are in tension, but finally when we find out we got this value as negative, that means the FBC BC bar is not in tension but in compression. Okay.